bigger tolerance? Bigger tolerance or smaller tolerance, which is better? Okay, Daniel, I ask you. Okay, which one is better? Bigger tolerance or small tolerance?
Hello, Assalamualaikum.
Yeah, salam.
Tolerance tu
Yeah, which one is better?
bigger lah kot.
Apa?
Sebab nanti bigger. Saya rasa bigger.
Bigger is better. Better untuk siapa?
Untuk manufacturer tu lah. Sebab nanti proses tu dia akan main value, dia akan main dalam range tu kan.
Okay. Any other opinion? Please, somebody else. Okay, Aiman. Okay, Aiman. Okay, which one is better? Small tolerance or big tolerance?
Kalau in my opinion, kalau big tolerance tu advantage dekat workers lah, sebab diorang dapat diorang tak terlampau stres untuk capai KPI tu kan.
Okay.
Kalau tapi disadvantage untuk manufacturers, contoh macam management lah, sebab maybe walaupun proses tu stable tapi tak semestinya output dia macam terbaik kan.
Okay, yes. Alright. So this is true lah. Maknanya for designer normally designer they want a small tolerance. Okay, designer. But for manufacturing they want it big tolerance. Sebab apa? Big tolerance is easier to produce. Tolerance besar lebih mudah untuk hasilkan banding dengan tolerance kecil. So manufacturer is happy if you give big tolerance, but the problem is the quality will be lower lah. Lower quality. Sebab kalau you ada two pieces of component, you nak cantum satu besar, satu kecil, jadi longgar, susah nak fitting. Okay, kalau kita buat fitting for two component, kalau tolerannya terlalu besar, okay, is not properly fitting. Longgar, senang cabut. Okay, kalau kita buat pintu kereta contohnya, ada frame dan ada pintu. Kalau tolerannya besar, pintu tersebut akan bising. Okay, ada berlaku gegaran dan sebagainya. Okay, so as designer is always targeting the best tolerance, which is small tolerance. As manufacturer, they want it to be a big tolerance because easy to produce. Okay, so this is the importance to know that CP, the value of CP. All right, you can switch off your camera. I will move on to the next aspect of process capability. We call it CPK. CPK. Okay, can I have opinion before I proceed? What is the difference between CP and CPK? Okay, anyone please volunteer? What is the difference between CP and CPK? Okay, tak ada nak volunteer ke? Saya panggil nama lah macam ni. Okay. Tanesh. Okay, ada dua Tanesh dalam kelas ni. Satu Tanesh Anatadan, satu lagi Tanesh Kumar. Okay, ada Tanesh. Please jawab kepada saya. Apa beza CP dengan CPK? Tanesh, are you there?
Yes, Doctor, I'm here.
Yeah, okay. What is the difference?
CPK is mainly used and mainly determined to measure difference between the desired and the actual value dimensions. While for CP, it is used to determine the whether the tolerance is suitable for the product or not.
No, it's not correct. Tak baca buku Baca tak ni?
Baca?
Baca. So it's not correct. So CP, kita tahu CP is a ratio between tolerance and process variation. Okay, the 6 sigma. Upper control limit, upper specification limit minus lower specification limit divided by 6 sigma. This is ratio for CP. CPK is different. Okay, CPK is different. Okay, can I have somebody else try what is CPK?
Sir,
Yeah, okay.
CPK is like how capable is the people who are manufacturing to produce the product that meets within the customer's specification that they have ordered.
Yeah, it is related to spec. What is the difference now? Why we need another index? We already have CP, right? Why we need another CPK?
To know whether we have fit the customer's demands or not.
Okay, what is the formula for CPK? What is the formula for CPK? All of you have the e-books, huh? What is the formula? Okay, can I try another one? Nur Fazira. Okay, Nur Fazira. Okay. What is the formula for CPK? Hello? Nur Fazira tak ada. Okay, CK.K. Who is this? CK.K. What is your full name, CK?
Yes.
Okay.
For the formula is maybe minimum of the new process mean minus the upper specific limit over 3 sigma, or using the mean minus the lower specific limit over 3 sigma. Most of the result can get the CPK.
So what is the difference from this formula and the CP formula? What is the difference? You notice that? What is the difference?
Different is over the sigma there. One is using 6 sigma, in one is using 3 sigma.
Okay. Okay. Why the bottom one is 3 sigma?
This one I didn't specify.
So not sure yet lah.
Yeah.
Okay. Okay, let me share with you the e-books. Do you see what I'm sharing now? Can you see the?
Yes, sir.
Yes,
Alright.
sir.
Okay, let's go to the page discussing this. All right. Okay, let me make it bigger. So this is in chapter 6. S, right? Yes. Okay, I hope everyone follow this. Here we have okay. So you see now the CP we have discussed, right? So I hope that you read these notes, the book. Okay. So this is CPK. Okay. the problem of CP is CP doesn't show the center. Okay, we don't know the center. Okay, but now there is limitation. Okay, there is limitation in CP. Okay, because of that, we need to get another index. Okay, another index, what we call it CPK. So you see here, CPK is proportion of variation 3 sigma, okay, between the center of the process and the nearest specification limit. So now the word center, okay, center. Okay, center come in, because what we have in CP is just a ratio of tolerance, which is upper specification limit divided by process variation with 6 sigma. Okay, it doesn't relate to center. Okay, so the problem is if the center move away, we don't know. Okay, we don't know, the process is actually no good, but the ratio is showing that this is good. Okay, yeah, I think there is a graph showing. Okay, so if I cannot find, no problem, I can just sketch here. Okay, for example, you have specification limit from this point to this to okay, let me, where is the eraser? Okay, for example, okay, your specification is let's say this is lower specification limit. Okay, I put it here, upper specification limit. Okay, you have this value. Okay, so in production, let's say during production, you're going to have a variability which is, let's say from here, okay, lower control limit, and this will be upper control limit. Okay, okay, so it looks like that process is in control or capable. Okay, because this value is smaller. Maybe this value you get it, let's say okay, 8 sigma. Okay, but this value you may get it, let's say 6 sigma. So the ratio, okay, remember, if we draw this line, so actually some of the item is already out, isn't it? You see this line outside specification limit, right?
Yes, doctor.
Yeah, it's outside. Okay, it's outside. So if I plot it in terms of normal distribution, okay, if I plot it in terms of normal distribution, you see that even it is process is considered as a good index. Okay, because if we get the index is now what is CP in this case? What is CP in this case? CP equal to what? Hello? What is CP here? Okay, someone please. What is CP now? Okay, can I have Tan Yi Tin? Okay, what is CP for this sketch here? Hello?
8/6, 1.33.
Yes, 8 divided by 6 equal to 1.33. Is it a good process? Is it a good process or not?
Yes,
Good.
sir.
Huh? Based on
Process.
huh?
Good.
Okay, based on earlier description, we say this process is capable, right? Process is capable. But if you see you see there are some portion of the data is outside. Okay, so if I plot the histogram to represent this, okay, you can see that, okay, some production will be outside the specification limit. Why? Because this part is outside the dotted line here. Okay, outside the dotted line. So if I plot this part, this part. I just continue this line. Yeah, I want this line. This line is showing this distribution. Okay, this is what you produce within this. This is the production. Okay, in fact, you have here this line. This line is a production. Okay. So the production line is actually produced outside specification limit. The specification limit, okay, if I may use different color here. The specification limit now, this is specification limit. Okay, specification limit inside, control limit outside. So meaning that this part is already reject. Okay, this part is reject. On the right side, it is reject. Okay, but on the left side, there is no problem because you still within specification limit. But the CP index showing it is good, 1.33. So is it misleading or not? Okay, so it is misleading. Misleading. Why? Because CP only compare the tolerance. This is the tolerance and the process variation without referring to the center. That's why now we need a center. Okay, between the center. So we need to refer to the center. What is the center? The center of the specification will be in the middle of this. Okay, the middle of between upper specification limit and lower specification limit, meaning that it has to be 4 here and it will be 4 to the left. Okay, so that's why we need another formula, okay, which is supposed to be giving better view of the process. So we call it CPK. Okay, CPK. It's a measure the difference between desired and actual dimension of the good. So X bar, okay, so we have here upper specification limit, okay, upper specification limit minus X bar. Okay, X bar will be the mean, the process mean. So now, where is the process mean here? The process mean will be here. Process mean, we get it from the data. Process mean is not from the specification. Process mean is from the process itself. So it is the middle of this distribution. Okay, so we see that between the middle for X sigma and the middle of 6 sigma already shifted. Okay, it's not the same anymore. Okay, it's not the same anymore. If I can draw it in simpler way, okay, we are looking at, okay, the mean has shifted in the example that I showed earlier. Okay, so what we have is this is specification. Okay, lower specification limit. This is upper specification limit. Okay, the center is of this nominal value is here, but during production, okay, let's say you are producing like this. So the center will be here. Okay, so this is the X, the process mean. Okay, the process mean. So now this center and the other center is not overlapping. It's not the same anymore. Okay. Okay. So we see that. Okay, there is limitation of value of CP because this one is not the same. This value and this value. Okay, so that's why we need to modify the formula. Okay, upper spacing limit, which is here, must be minus X bar. X bar is coming from the process. Okay, X bar is coming from the process. Okay, the mean for the process. Okay, the mean for the process, comma. Okay, X bar minus lower specific limit, which is this bar, lower specific X bar, which is here, higher value, because we take this X bar opposite of the first one, minus lower specific limit. Okay, so we divide by 3 sigma. Okay, we divide by 3 sigma. This is 3 sigma. The 3 sigma is coming from here. The 3 sigma is here. 3 sigma. And this is 3 sigma. Okay, because why? The whole normal distribution to the left, to the right, remember I mentioned last class 99.73% is covered by plus minus 3 sigma. Okay, covered by plus minus 3 sigma. So meaning at the whole range. So now that's why we divide to the left. Okay, this is 3 sigma to the left, to the right, sorry, 3 sigma to the left. This is what we do here. Okay, so in this formula, we include this process mean, okay, process mean, which is the center. In the statement here that the proportion of 3 sigma between the center of the process. Okay, this is the center of the process. Okay, from here, so we know actually the behavior of the process, whether the center have shifted or not. CPK did not show any shift in the center. Okay, so in this case, center is shifted. Okay, we know using a CPK, we know that the center have shifted. But if you use CP, we never know it is shifted or not. But the index may show that the process is capable, but in reality, the mean may have shifted. Okay, this one is mean shifted. Okay, so kalau mean dah shifted, you need to make adjustment to the process lah. Okay, all right. So let's see example. Okay, in this example, you are the process improvement manager and have to develop a new machine to cut insole for company top of the line running shoes. You are excited because the company goal is no more than 3.4 defects per million. Okay, 3.4 per million, and this machine may be the innovation unit. The insole cannot more than plus minus 0.001 of an inch from required thickness of 0.250. Okay, this is American textbook. They're still using inches. Okay, because we follow metric system. Okay, doesn't matter. Okay, you want to know if you want to replace the existing machine, which has CPK of 1.0. Okay, you want to know if you should. Okay, you should replace the existing machine. So now you want to know whether should you buy a new machine. Okay, should you should replace or not the existing machine. Okay, the existing machine has CPK of 1.0. So the mean of the process is given here. Okay, 0.25. Standard deviation is given. Okay, process standard deviation for new process 0.005 inches, and you need to decide okay, determine the CPK. And remember, among these CPK, we need to choose the minimum value. Okay, the minimum value between this and this. Okay, whoever give the lower value, that one is the CPK value. Okay, so upper specification limit, we know that specification is given. Okay, we have plus minus. The required thickness is 0.25, right? 0.250. Okay, plus 0.001. So that giving you the upper specification limit of 0.251. Okay, this is what we got here. Okay, so the mean, the process mean is given here. Okay, this one. Okay, divide by 3, sigma. Sigma also given in this case. Okay, so the same also for this one. This is X bar. This is lower spec limit. Okay, this is 3 sigma. So just solve this problem, we found out that, okay, actually what we got is 0.67. Okay, because the machine has CPK of only 0.67, now new machine should not replace the existing machine, because the existing machine has 1.0. This one is because you are evaluating, okay, the new process, okay, the new machine, okay, the new machine. This is for new machine. Okay, new machine is no better than the existing machine, so we should maintain the existing machine. Okay, all right. Okay, this is the figure that I was looking for. Okay, this is another way of looking at this aspect of shifting. So we see here negative, CPK negative number, process does not meet specification if CPK have negative. Okay, in this case, this is the process. Okay, this is the process. This is also the process. This is also the process. So the best process is what we have here. CPK greater than 1. Okay, when you have CPK which is greater than 1, okay, process is better than specification. So we wanted a small, okay, a small normal distribution, because you have specification here, lower spec, okay, upper spec. Okay, so your tolerance is enough, okay, for this production, because the variability in the process is this within the specification. This is what we want. Okay, so if you have CPK greater than 1, okay, definitely CP also greater than 1. Okay, if you have CPK equal to 1, as what we see here, exactly online, we just met the specification. Okay, it is center. The center is the same. The center for spec and center for the process. But if you have CPK between 0 and 1, which is CPK less than 1, CPK which is less than 1, process does not meet the specification. You see here the center of the process has shifted. Supposed to be here, but now it's shifted. Okay, so this process is producing a lot of defects. Okay, this part is outside specification. Okay, outside specification and must be rejected. And we can adjust this if the setting of the machine can be adjusted. We can adjust this, bring this back to the center. Okay, so this is where it can guide us to do adjustment of the setting. Okay, so if we have like this, CP equal to 0, if you see the middle of this, the middle of the process equal to the specification limit, so you get CPK equal to 0. So this is process is having problem because spec here, but you are producing away from the spec. Okay, if it's negative, it's even worse. Okay, negative number, process does not meet specification because specification is here, but you are producing somewhere from here to here. Okay, I hope that clarify the difference of the CP and CPK. CPK is telling us on the center, okay, which is a better measure compared to CP. Any question? Hello?
Sir,
Yes.
kalau macam defects tu,
Yeah.
dia boleh jadi dalam measurement dengan bilangan bilangan defects.
Measurement atau bilangan. Okay, maknanya attribute ataupun variable, is it? You asking that?
Sebab contoh kalau macam soalan example tu kan
Yes.
macam plus minus 0.01 specification tu kan.
Yes.
Tapi contoh kalau macam baju kalau ada koyak-koyak ke tu macam mana dia kira kalau dalam proses capability.
Okay, proses capability, kita kena ingat proses capability ni kita cuba bandingkan specification dengan tolerance, tolerance dengan proses capability. So kita ada target. Okay, our target value is here, tapi we are allowed to varies between the specification lah. Okay, so normally it's become critical if it is for measuring variable control chart. This is very relevant to X bar chart. Okay, X bar chart. Okay, kalau X bar chart, it is very clear lah. We are using this control chart for monitoring the targeted value, and then you may have this is your specification. Okay, specification biasanya mesti lebih besar daripada process variation lah. Otherwise, you're going to have a lot of rejects. Okay, so it's X bar chart. Okay, so our target is here. We have a target. Okay, we have a target there. So back to your question. Okay, back to your question, you kata tadi kalau nak menyemak contohnya bilangan kecatatan kepada pemeriksaan baju. Okay, you have a baju, and then sekarang ni you nak tahu whether your pekerja, the workers that producing baju is capable ataupun tidak. You still can use this CP because we know that in any process, tak ada perfect process. There will be somehow allowable variations. Okay, tapi tak boleh lebih daripada limit yang ditetapkan lah. So in this case, okay, kalau saya rujuk kepada X bar chart, kita ada garisan tengah. This is X bar. X double bar garisan tengah. So we are targeting to achieve this target. Okay, to get the target. So another way to look at it is macam katakan you ada satu bar pin ini you ada target value. Target value pin ini sepatutnya katakan 10 plus minus 1.0, katakan macam tu. So this one is aku 10 lah. Ke sana sepatutnya 9. Ke sini 11. Anything between 9 dan 11 is acceptable. Okay, it's very clear kalau measure macam tu. Tapi kalau dalam baju, okay, baju, kita boleh gunakan process capability juga. Tetapi di sini will be average of defects lah. Contohnya kita katakan, okay, kita menggunakan P chart. Dalam P chart is proportion of non-conforming units. So mungkin katakan your center, okay, what is the target ataupun the average, okay, the average of defects. So mungkin you kata P here will be equal to, okay, 0.1. Of course, what we want is kalau 0.1 tu sebenarnya besar tu, sebab 10% of the baju katakan reject. You produce 100, 10 baju rosak. This is not good lah. Tapi just for the sake of discussion, so your target will be here. Seperti yang saya kata, dalam P chart, kalau dalam case inspection ni, the lower is the better. Okay, biasanya kita guna kosong sini kan. Sepatutnya target kita kosong lah kan. Tapi oleh kerana we want to be realistic, somehow that we have to accept that pekerja memang tak perfect, impossible dia nak dapat kosong reject. Maybe dia akan dapat daripada 10 baju mungkin kita katakan satu baju rosak. That will be the mean. Okay, kalau that is the mean, so your normal distribution, kita boleh plot normal distribution juga di sini sebenarnya. Okay, normal distribution. Based on that normal, okay, as long as you can plot normal distribution, okay, this is from the process that the target. Sorry, dalam P ni dia binomial, okay, binomial dia punya distribution, it's not normal distribution. Okay, sorry that binomial distribution dia bukan normal distribution, okay, sebab dia either yes or no, itu saja. Jadi dalam kes ni masih boleh guna, kita boleh masih guna the concept of apa ni CP tadi, tapi dia tidak sebegitu relevan lah kalau compare dengan menggunakan variable control chart. Okay, sebab CP di sini adalah especially CPK CPK tadi, kita nak compare dia punya shift upper spec, okay, minus X bar, okay, and then X bar minus lower spec limit, okay, divide by 3 sigma, divide 3 sigma. Jadi kebiasaannya kita menggunakan CPK ni untuk X chart, okay, X chart. Jadi kalau kita gunakan dalam kes baju ni tak berapa kena lah sebenarnya. Boleh nak tunjuk tapi sebab satu ialah target ni apa? Target. Kalau sini target kita sini, sebenarnya target kita adalah kosong sebenarnya. You nampak tak? Biasanya lah dalam application ya will be for X bar chart. Kalau kita nak gunakan ini sebagai target, kita akan guna P itu sebagai target dan kita bandingkan dengan the X bar will be the P value lah. Okay, and then kita ada upper spec di atas, lower spec di bawah. And then 3 sigma tu masih 3 sigma, tapi sigma ini adalah berdasarkan kepada nilai P yang kita tengok sebelum ni which is P bar minus 1 P bar, okay, divided by N. Okay, so I think for the purpose of your understanding, but this class doesn't go in detail of this topic, kita just introduce saja. Okay, so jadi to be on the safe side, okay, you remember that it is for X bar chart. Okay, kalau menggunakan di sini dia require the target yang acceptable in the company lah. Berapa company willing to sacrifice the defect among the workers. Okay, the ideal situation should be 0. Tapi dalam case is very clear, this target we want to be in the middle. Okay, because dimension kan. Di sini we want to have 0, but 0 kat sini is not in the middle. In the center for using this formula adalah average ataupun the target value for P tadi. Yeah, I think that's the best explanation that I can provide kat sini lah. Okay, so jadi we have to be careful lah kalau you nak pakai untuk jenis macam baju apa semua tu, sebab our target kalau attribute is we want it 0. Kalau boleh kena 0 defects. Yeah, that should be the best lah. Okay Hello?
Okay, sir.
Alright. So it's not so much relevant lah kalau kita tengok untuk P tadi. Sebab target P adalah 0 tapi the middle is not 0 Dan lagi pun formula dia menggunakan X bar. Okay, unless you assume that X bar itu sama dengan P bar lah. Okay, X bar itu maknanya center of that measured values. Okay, so later on I will let you do some exercise from this end of this book related to that. Okay, I want to move on to chapter on project management, chapter 6. Do you need a break or can we take a 5-minute break? Hello?
Boleh, sir.
Boleh, sir.
5-minute breaks, So, and then we go to chapter 6 on project management. And important topics, very important topics. Okay, project management chapter 3, sorry saya salah cakap tadi. It's not chapter 6, it is chapter 6 quality kan. Alright. Hello, boleh kita teruskan?
Boleh,
Boleh,
Doktor.
Doktor.
Alright, so I move on to new chapter, new topics, new chapter, which is on chapter 3. In chapter 3 of your textbook, okay, okay, kalau saya boleh tunjukkan sini your textbook, I think I have it here. Okay, your textbook, nampak on the screen, textbook.
Nampak sir.
Okay, please read this chapter. I will explain, but also you need to read. We already specified the topics that for this chapter is from page, I think you need to read from page 62 until 86. Okay, very important chapter. I think in your mechanical engineering courses, this is the only course that you learn about project management, unless you take elective for project management. And project management knowledge is very important. Okay, project management knowledge is very important, and is one of the requirement by Board of Engineers. All engineers must know how to manage projects, because somehow maybe sometime in your career as engineer you will be working for projects. Okay, so before this, have you heard about project management or not? Okay, can you respond to chat box? I want to know whether you have any experience or not in project management. Maybe you have seen somewhere else. Any exposure on project management? Can you respond to the chat, please? Project management experience. Okay. Okay. Quality management pernah, project management tak pernah. Okay, never heard about it. Okay. Okay, before I explain more detail, I would like to know what is actually project. What is project? Can you just respond to the chat? What do you understand about project? What is project? What is project? How project different? Okay, maybe I can put like this. How project is different? It's different than routine activity. Routine activity is something that we do every day. Every day we do routine. Okay, every day we cook. Okay, we eat. Okay, this is routine. So cooking in the kitchen is not a project. Okay, large scale task. Okay, that is important, that need proper planning. Yes, correct. But if you are cooking for konduri kahwin, so it can be a small project there. Okay, a family project. Okay, going out, make a barbecue. Maybe you do it maybe every 3 months, you go once. So you can say this is a small project. But if you goreng ikan kat dapur, it's not a project. Because why? You do it regularly for that one. Okay, any kind of objectively event. Okay, project is a task which has a specification we need. Okay, any kind of event, benda yang kena research and design. Okay, like you are asked to do group projects. Okay, something that is you still not clear what it is. Okay, something that you need to do in group. Yeah, this is a project. Okay, so in engineering, we tend to find, okay, many activities are done as a project. Okay, it's done a project. So we're going to study in this class, in this topic, what we call this one is, you see on the screen now or not, the network diagram? Hello, please respond. You see or not?
Nampak, sir.
All right, yes. Okay, this is what we call it, network diagram. We're going to study how to prepare this network diagram, okay, to manage a project. Okay? So, and in doing this, when we have that project network, we also have to consider variability. Okay, variability in estimating project times. Sometimes project delay because of maybe some disturbance ataupun wrong estimate of timing and so on. We're going to study here only for 2 weeks on project management, but the topic is so important. Any one of you interested to learn more about project management, you can take elective. So saya last semester, I think the last 2 semesters, okay, 1 year ago, okay, saya dah ajar subjek ni, and some I think most of student are from mechanical engineering student ambil subjek ni, and then and one of the student, at least one lah yang contact saya, dia kata dia surprise dia dapat kerja menggunakan project management yang dia ambil sebagai elective course. Okay, so she was very happy, and then saying that, you know, just to say thank you because of learning project management, she got a job. So to show that it is an important topic. So walaupun you pure mechanical, okay, but you need project management knowledge to handle projects. There are so many projects out there. It could be renovation projects, it could be construction of new bridges, new building, or maybe construction of new factory, or even new product development. Okay, you introduce new products. Okay, so also can be a project. Okay, let's me go more detail here. Okay, nampak saya punya PowerPoint? Hello, I'm sharing with you PowerPoint now. Is it okay? Nampak?
Sir.
Yes or no?
Nampak, sir.
All right. So
Yeah.
this example of projects, okay, building construction is a project. If you see, you go out there outside from your house, you can see maybe something road repair, okay, perbaiki jalan. So it's also project, small projects, okay. So project management knowledge can be used for small contractor, big contractors, you know. And then you can see that house renovation also a project. Kalau nak buat kenduri, wedding, reception, okay, inviting 1,000 people to come in and have you know, lunch or dinner, it's also a project. Okay, so we need to know how to manage projects, because if we don't properly manage, it's going to be very costly, dan juga tendency that the project is failure and it can be havoc lah. Example of project in engineering, engineering projects, new product development ataupun overhaul. Okay, overhaul bermaksud sometimes that company would like to have maintenance, so it can be a project also. Company shut down and to maintain and to repair dia punya facilities, okay, nak tukar komponen-komponen yang telah berkarat, the house dan sebagainya. This can be also a project. Okay, a research project like you are going to do in your group is a research project. Computer and IT projects, you develop a new software ataupun new apps, application yang baru. Managing COVID-19, is it a project or not? Okay, can you respond? Okay, COVID-19
Project.
is a project, okay, because we don't do it COVID every year, every day. During this period of time, management of apa ni, handling tackling of project apa ni, COVID is a project. Kalau kita ada banjir ataupun bala apa kita panggil this petaka, apa kita panggil, and this earthquake, flood and so on, this also can be treated as a project. Okay, we need to manage it properly. Okay, otherwise we are not able to overcome the problem. Okay, so what I'm trying to say is project management is very important. It can be applied sama ada in services, in product development, in engineering, in society, in for example hosting a tournament, okay, SEA Games katakan contohnya, ataupun Olympics. This also projects. Okay, we need knowledge in project management in handling that. Annual dinner for company. Okay, company want to have annual dinner. It's also a project. Okay, I think that's enough for example of what is project. Okay, let's move on. What is characteristic of project? Okay, some of you have mentioned just now that it require complex, it require you know, coordination. A project is a single unit normally. Okay, you make a house is a single unit of house. If you make a car, especially the new model, it will be a single focus unit. Okay. Of course, this is not restricted. It must be always one. But what I'm saying is there is something that you focus on to address that. Maybe the project of apa ni katakan installation of new machine in the factory. Okay, as a single unit there. So maknanya is one off. Maksud di sini one off. There is a beginning, there is ending for the project. And project has many related activities. It is difficult planning. Okay, kalau we relate to production in manufacturing, is difficult production planning lah. And require general purpose equipment because from phases to phases, you're going to have a different type of activities. And the workers that work on a project must be high skill level because at the beginning maybe the work is mungkin katakanlah kita refer to construction. At the beginning is maybe clearing the site. After clearing the site, the same worker may be using for doing the landscaping, okay, doing some structure work and so on. Okay, depend on the size of the project. Okay, project management becoming more important, okay, because it's compression of product life cycle. Okay, product life cycle, PLC, I mean here is product life cycle. As we see now, the product life cycle is becoming shorter and shorter. In the past, kalau you tengok model kereta, it will be in the market for maybe 5 years. But now, a new model coming in maybe every 1.5 years. Even kalau tengok phone, okay, every year come up with a new model. Okay, maybe less than 1 year. So this is the meaning of shortening product life cycle. Kita hayat produk dalam pasaran menjadi semakin pendek. So ini menyebabkan project management becoming more important because engineer keep busy innovating new design, new model, new features and so on. Okay, so they work as a project. Any new product is treated as project. And also global competition, okay, persaingan secara antarabangsa menyebabkan we need to move faster, treated everything as a project. Rather than routine, there is a difference between project and routine. Routine ni seperti yang kita buat everyday lah, seperti saya mention tadi. The opposite of project is routine activities. Okay, we don't have to think, we don't have to plan in detail lah kalau routine. Something routine, you do it every day, tak fikir pun dah tahu dah nak buat apa. Okay, contohnya lah, something that routine. Kalau you stay in the house, okay, you cook for your lunch or your majlis iftar di rumah, mungkin it's not a project. Tapi kalau you buat iftar, buka puasa untuk menjemput anak-anak yatim, okay, kita buat mungkin sekali dalam bulan Ramadan. So that is a project. Okay, that is a project because you don't do it as a routine. Okay, so another aspect of why project management becoming important is because now knowledge explosion. Now we have a lot of knowledge, we have a lot of information, new innovation. Okay, so require to be handled as a project. Okay, downsizing of project. Some company, corporate downsizing because of competition. Some company being mereka reorganize balik. So mereka melaksanakan aktiviti masyarakat sebagai project. Okay, instead of routine. Okay, maknanya from routine, some activities are converted as a project. Because apabila project kita nak monitor, nak measure, it is clearer. You treat it as a project. Maybe small project lah maksudnya. Increase customer focus when you have project customer focus. Okay, for example, you have a manufacturing. Okay, manufacturing nak buat kek raya, ni musim Ramadan nak buat kek kan untuk raya. So boleh treat that as a project. Project raya. Okay, nak dapat income lebih. Okay, duduk kat rumah. Okay, mak buat bisnes sikit-sikit. Kita tahu, okay, kita buat project. Jual biskut raya. So we can create as a project. Okay, create as a project because that will give you focus. Kalau you buat just a routine, we are not focused because kita buat untuk cukup makan, untuk without any big objective to achieve lah. Okay, small project represent big problem. Okay, so maybe a big problem we break down to small. Okay, small pieces also can. Okay, we treat that as a project, solving it as a project. Okay, jadi lebih fokus. Alright, so in project, please remember this, in projects you have three phases. You have planning phase, you have scheduling phase, and you have controlling phase. Okay, so in planning phase, we are doing, what we need to do is, we have to define, set the goal, define the projects, and come up with project organization. Okay, planning. What important here is WBS, but I'm not going to go in detail on that because we only have 2 weeks. WBS, work breakdown structure. Work breakdown structure is actually it's important for us to know that during planning lah, during project planning. Okay, so we do it work breakdown structure. We also need to know the team organization, or we call it OBS, organization breakdown structure. Okay, so in defined phase, we plan for the work breakdown structure and organizational breakdown structures, and also we come up with a document, what we call it a statement of work. Okay, we call it SOW. Okay, statement of work ataupun project charter. Okay, another way, simpler way to say that we have it as a project proposal lah. Okay, project proposal. So this is what we do during planning of the project. Project proposal. Okay, in project proposal ataupun saya sebutkan tadi statement of work, statement of work. Ataupun statement of scope of work. Okay, you can call it scope of work or statement of work. Scope of work lah. Okay, let me check later whether what is the common S here. But it's referring to statement or scope. Referring to scope also can. Okay, scheduling. This is where you are talking about scheduling the time. Okay, the second phase is scheduling the time. And also you need to schedule the resources. Resources for the projects can be equipment, it could be the money that you have, the budget you have, okay, the material you have, the equipment you have. So we schedule the time and also resources when to use it. Controlling is for monitoring. When the project started, you need to monitor the projects. When the project is on schedule, project is overspending, okay, and we need to have monitoring. Okay, so it's common also for mechanical, electrical, civil, working on projects. So you need to monitor, you need to make sure that what is being decided during planning is implemented. Okay, so if we relate this in this diagram, you can see like this. Okay, this is what we can see in project planning. We have to have the objective, we identify the resources, we know the work breakdown structure. I mentioned just now, work breakdown structure. We also need to know the organization of the projects. Okay, so in scheduling, we know the activities for the project, we know when the activity start, when activity finish, and we produce the network diagram. And the last phase is controlling. So remember that project management activities have planning, scheduling, and controlling. Okay. So controlling is require us to compare what we plan with the actual implementation, and then you may need to revise. Okay, revise for corrective action. All right. So if we put it graphically, this is a planning phase. Okay, the planning phase of projects. Okay, we are planning first. We need to know the goal of projects. Goal of project is triple goal. We call this is triple goal. Triple goal of project is time, cost, and performance. Okay, time, cost, and performance. Performance here is referring to quality. Quality of projects. So this type of goal is normally is conflicting. You want a cheap projects, but at the same time you want it fast to be finished. So it's not easy to achieve that. Normally, good projects can require enough budget, okay, will be require enough time to deliver, and also you have a good quality. Okay, if you want to reduce the cost for project, you will affected. Okay, the quality affected, time also affected. Okay, so these are triple goal for the projects. We call it. Okay, you have time, cost, and performance. Okay, these are conflicting goals. Okay, so a good manager can make a balance. Okay, within the budget and deliver on time and acceptable quality. Okay, to define the projects, this is I call it what I mentioned just now, project charter, like a project proposal, where we put the detail of the projects in this document. Okay, project charter. It is a reference document for the client, okay, pada pelanggan dan juga kepada contractors. Okay, so you have that defined in or some people call it SOW, okay, statement of work. Okay, and then we have work breakdown structure. Work breakdown structure is where we have a project at the top, and then we break down the activities of the projects. Okay, for example, we buat project katakan renovation, kitchen renovation. Okay, this part may be creating the structure. Okay, the left part, ataupun this part katakan you are doing the demolish of existing structure. This one is building the new structure. The new structure akan ada mungkin buat tiang, mungkin buat dinding, ada buat electrical. So this is basically we call it breakdown structure. Okay, work breakdown structure. And then after that, you also need to have responsibility matrix. We call this organization. This is identify the team and resources. Okay, sometimes we call it responsibility matrix. You want to give responsibility, who will be responsible to do what. Okay, so where you assign the workers, okay, and the activities together. So this is the planning part. Okay, and then the second part is, okay, I'm just repeating what I've said earlier. The second part is scheduling. Scheduling the project, where we are using the precedence, the sequence of activities. We need to have precedence. We have to have precedence diagram. Okay, this is like when you are taking some courses, you ada prasyarat kan. Precedence macam tu lah. You cannot proceed let's say this activity 1, this is activity 2, this is activity 3. Okay, you cannot proceed activity 2 until 1 is finished. Okay, so we use node, okay, to represent activity. Okay, okay, so we can use this arrow just is to joining lah. Okay, joining the logic, showing the logic between one node and another. So ada juga kaedah yang menggunakan activity on arrow, activity on node. Okay, activity on node. So but the most popular is activity on node lah. Okay, activity on node. Mana node yang bulat tu sebagai activity. This is how we represent in the network diagram lah. Activity on node. This is a common one lah. Okay, kalau kita AOA, this is activity on arrow. Okay, activity on arrow. So this one is easier lah. Activity on node is easier. Okay, and then we convert that into Gantt chart. Okay, Gantt chart. This is Gantt chart. Okay, and then finally we convert to calendar lah, schedule into calendar. So all this actually can be done using a software. Okay, for example, Microsoft projects. Okay, in practice, most likely you're going to use software, but before you can use software, you need to understand the theory. Otherwise, you might make a mistake in using software without understanding. Okay, Microsoft project is quite common lah in using or managing projects. Alright, sampai situ ada soalan tak? Hello?
Tiada, sir.
Ada, okay. Okay, let me move on. I want to explain a little bit more on work breakdown structure. Okay, maybe I show you a sample of statement of work. Okay, let me find from my computer here. Example. Just 1 minute. I'm getting the slide here. Okay. Okay. Do you see here what I'm sharing here? This just to show you example of a project. Nampak ya?
Pak tu.
Okay. So this is an example of a small project. We design bedroom interior projects. Okay. So in this project, okay, this is the name of last time I was involved with Telco University kat Indonesia. They invite me to give lecture on this. Okay. For example, in planning, you need to have a goal. Okay, goal for projects. Okay, goal of the projects. Okay, this is one group of students. They just make a small project to demonstrate understanding of project planning. So we have a goal. What is the goal? The goal is, for this case, is to redesign the bedroom. Okay, you have to specify that. What is the requirement there? You need to have a finance quality, excellent service, and so on. And then these are what we include in the document. Okay, in the planning stage. Okay, in the planning stage, you must have a goal. Okay, goal for the projects, and then of course you have segmentation. You need to identify your customer. Okay, the layout, the execution, and so on. Okay, and then okay, I think I want to show to you. Okay, I think this is not the best example. Okay, let me find another example. I want to show to you the statement of work actually. Statement of work. Okay. Just 1 minute. Okay. Can you see the screen now? Hello?
Nampak sir.
Nampak eh? Okay, this is statement of work. What I also mentioned is now we do it in planning, during planning, project planning. We make a statement of work, ataupun we call it project charter. Okay, project charter. So where we spell out between the customer, the client, and also the contractor lah. You must have that agreement in the planning. Otherwise, you're going to have a lot of problem later on if the statement of work is not clear. Okay, this is like we call it project charter. In a bigger project, they call it project charter lah. Okay, small project you can say statement of work lah. Statement of work. Okay, statement of work. Ataupun dalam statement of work ni kita akan masuk scope of the activities lah. Okay, so another way to say is project proposal lah. Okay, project proposal. It's referring to the same meaning lah. Okay, project proposal. But if we say project charter, it looks at okay, it looks more professional lah, project charter. Okay, statement of work. Okay, kalau project proposal ni anything can have in that proposal kan. Okay, so in this case is renovation projects. Let's say yard renovation projects, mungkin nak buat renovasi taman. Okay, so you must have the objective. Okay, for example, the objective of renovation cannot exceed this amount of money. Okay, to design and construct high quality yard. Okay, berarti mungkin nak buat taman, kita tak boleh exceed this certain amount of money. Okay, and then what is deliverable? Okay, in project we always refer to deliverable. Okay, kita specify, this is basically specification. Specification. So in specification you specify what is the size of yard. The yard should be this meter. Okay, space dia berapa banyak. Begitu juga kalau buat renovation kitchen renovation, katakan okay, the kitchen must have finishing of marble jenis macam mana atau tiles macam mana. Is it included the hook for the kitchen, and then the finishing in the kitchen tu kabinet dia termasuk ataupun tidak. So we spell out in that document of project charter lah. Okay, the finishing dia macam mana, the furniture macam mana. Okay, and these are basically specification. And then you also need to include the milestone. Milestone is something that we check from time to time. When is the date? For example, some important progress in the project. Okay, that is milestone lah. Okay, maknanya by that January, this date, I want it, everything is clear. Okay, picking up trash and fixing the backyard and so on, and the architectural design and so on. Okay, this is milestone of that project activities. Okay, you have a planting of the trees, or maybe some bunga dan sebagainya lah. Putting the furniture and then final inspection. So all these are, we call it milestone. Okay, for the project, where it's a checkpoint lah. Okay, milestone is checkpoint. You have many activities, but to monitor a project, you need to have a checkpoint. Okay, and then the technical requirement. Okay, so we convert that specification in technical requirement. Okay, for example, you want it more specific, lighting macam mana, flooring macam mana, okay, furniture macam mana, and so on lah. Okay, apa yang terlibat dan apa yang tidak terlibat, what is included, what is not included. Okay, so this is we call limit and exclusion, because when you do a project, sometimes there will be dispute between the customer and the contractor. Kalau tak spell out clearly, okay, customer expect pagar dimasukkan dalam projek, tapi customer kata you tak pernah mention pun pagar termasuk, kita hanya buat bangunan sahaja. Okay, ataupun dia kata you expecting all the landscape is included dalam pembinaan before handover. Tapi kalau tak dimasukkan dalam dokumen, you have no way that to dispute, okay, to dispute with the contractor. So we need to put what is limited and what is included, what is not excluded. Okay, The yard will be designed and constructed by customer. So this is the responsibility of customer. Okay, the owner responsible for landscaping. So this is very clear. Now this is like putting the scope of what is included and what is not included. Okay, the working hours limited. So some places dia tak pernah akan bekerja outside the office hours. So you must mention that to the contractor and so on. Okay, and then after that maybe you have to get the customer review. Okay, whether they agree or not with your statement of the work. So this is we call statement of work, which is done during the planning stage. Okay, let me move on to okay, stop there. Okay, let me move on to another aspect of planning. Another aspect of planning. Okay, what I say just now is work breakdown structure. Okay. The work breakdown structure. Okay, you nampak tak apa yang saya share sekarang ni? Hello?
Tak nampak sir.
Tak nampak Okay, I want to show something that we are doing during planning also for projects. Okay, sekarang nampak ya? This is let's say bedroom, redesign bedroom interior. Okay. So nampak dia punya decoration banyak kat sini Okay, this is what we call it. Nampak ya sekarang? Hello?
Sir, nampak.
Okay. So what I'm showing here is during the project planning still project planning. Remember the project has 3 stages project planning, project scheduling and project control So in project planning, selain dia kita come up with document tadi, statement of work dan sebagainya, we also do what we call it WBS. Apa itu WBS
Work breakdown structure.
Yes, correct. Work breakdown. So this is example of work breakdown structure. Kalau kita nak buat bilik tidur, nak renovate interior design dia mungkin dah beli rumah, tiba-tiba kita nak masuk tak selesa dengan apa yang developer bagi. Kita nak panggil dulu renovation, nak buat bedroom yang lebih special. So first is you may have to redesign the bedroom. Okay. So these are some of the activity yang terlibat design, and then look in the structure, you look at the utilities, look into finishing. Okay, ini maksudnya work breakdown structure. Kalau dalam produk kita panggil product structure. Okay, kalau product structure. Kalau product structure ni, saya tak pasti you being explained or exposed or not. Product structure. Dalam design you ada belajar product structure ke? Hello, can someone respond to me or put in chat box? You know what is product structure? Pernah dengar tak perkataan product structure? Wow, tak pernah dengar. Product structure, okay, product structure, for example, I just take example, katakan you have fan, okay, fan, kipas, table fan. Okay, table fan. Kalau table fan, kita ada apakah basically lah macam assembly drawing lah, tapi ini kita industrial engineering, we call it product structure. Tapi not exactly macam production drawing, dia lebih menunjukkan structure of that fan. Fan ada dia punya body ya. Apa yang ada lagi badan body of the table fan, body, lepas tu apa dia punya tu? Blade kan?
Electric motor.
Blade. Lepas tu dia electric motor. So this kita panggil product structure. Okay. So dalam body mungkin body ni dia ada stand dia kan. Okay, mungkin tak accurate saya tunjuk, tapi saya nak tunjukkan bahawa kita boleh pecahkan. Body tu ada stand, ada apa lagi? Mungkin ada switch kat situ. Okay, mungkin ada dia punya base, kaki dia. Okay, kat blade dia ni pula ada dia punya cage dia kan, sarang dia. Okay, dia punya blade tu sendirilah. Okay, mungkin situ ada mungkin some of the bracket, something like that. You know? Kalau electric motor pun ada part-part dia. So ini kita panggil product structure. Boleh faham ke? Hello?
Boleh sir.
Okay, so kalau dalam projek, kita panggil work breakdown structure. Dia merangkumi aktiviti yang terlibat di dalam renovation tersebut. Okay? So jadi, aktiviti daripada WBS ini kita akan convert kepada activities. Okay? Kepada activities yang akan dimasukkan di dalam network diagram nanti. Okay? So, of course kita kena relatekan dengan organisation structure dan sebagainya lah. Okay, I think that one is enough for you to introduce this. I want to move on to project scheduling. Project scheduling. Okay, for project scheduling, okay, mana saya punya PowerPoint tadi? Right, I think this is the one, okay. Okay, nampak sekarang? Hello? PowerPoint project planning, nampak?
Pak sir.
Right, okay, bagus. Okay, so saya dah explain tadi apa itu yang kita lakukan dalam project planning. Dalam project planning biasanya we are looking for defining the project. Apa dokumen yang kita gunakan untuk define project tadi? Hello? What is the name of document?
SOW.
SOW. Okay. Ataupun project charter. And then we create the breakdown structure. Okay, breakdown structure ini macam tadilah. Kita breakkan structure dia. Okay, macam organisation structure tapi instead of orang, tapi kita letakkan component, parts dan sebagainya. Okay, this is for the project lah. SOW. And then we have to determine the resources and we form the organization that going to manage the project. Okay. Okay, this is organization. We're not going to go in detail on that. Okay. Okay, I want to go to the project network. A little bit of project network before we stop for today. Okay, the project networks. Yeah, I just want to briefly introduce your project network and then we stop lah. Okay, in a few minutes. Okay. Okay, dalam projek projek apa ni kita panggil schedule, project schedule. Okay, before we go to project schedule, okay, let me show another example. This is work breakdown structure. Dia ada level dia. The project is level 1, level 2 is major task, level 3 is subtask, and level 4 is activities, or we call it work package. Okay, so apa yang kita akan masukkan dalam project adalah this is activity dalam network, work packages. This one will go to network diagram. Okay, this one will go to network diagram, which is the lowest level lah. Kalau kita tengok dalam hierarchy tadi, dalam product structure tadi, dia macam ni lah. Project tu buat dekat sini, lepas tu dia go to major task ni subtask, sampailah ia ada activities, level 3 and then level 4. Okay, so we call it work packages. Okay, work packages. Okay, example dia kat sini. Okay, you can see this work packages. Okay, work packages. So maybe small contractor will get one work packages lah. Okay, kalau this is example for software development, but kalau construction there will be the work packages. Different small contractor will get small work packages to contribute to the whole project. Alright, so scheduling, this is scheduling aspect. Seperti yang saya sebut sebelum ni tadi, kita akan membuat second phase of project management is scheduling. Scheduling. After planning, scheduling. Okay, scheduling. Scheduling, kita ada Gantt chart, kita ada critical path method, kita ada PERT. Okay, so in order to do this, you need to this example of Gantt chart after kita dah buat network diagram lah. Okay, so kita dah sebut tadi sebelum ni berkaitan dengan activity on arrow or activity on node and activity on arrow. This is where you use it during scheduling. Okay, scheduling. Okay, so simbol di sini menunjukkan bahawa bulat is node. Okay, dan kita ada juga arrow ni, arrow. Kalau kita guna activity on arrow, this arrow is activity. Okay, this is activity. The arrow itself is activity. So dalam sini node di sini, kalau activity on arrow, node ni menunjukkan start ataupun finish. Okay, so kalau we look at this arrow, this is start of activity A, finish of activity A di sini. Okay, finish ni juga, this the same node merupakan start of activity B, finish activity B di sini. So this node mewakili start and finish for activity, finish activity A but start for activity B. Okay, kalau this node pula finish activity B, start for activity C. Okay, so jadi node ini boleh merupakan start or finish. Tapi kalau kita menggunakan kaedah activity on node, so this is activity A, arrow tu hanya menunjukkan logical relationship sahaja. Okay, kalau B ini menunjukkan activity A dengan B must be completed before C boleh dimulakan. Okay, macam ni lah, kalau you nak pergi LI, mesti ambil subjek yang prasyarat untuk LI. Kalau tidak, tak boleh pergi LI. Ini maknanya ada prasyarat. Okay, so itu maksudnya di sini. Okay, so there are many other possibilities lah. Kalau dalam case activity on arrow, kita memerlukan dummy. kita memerlukan dummy. Kerana menunjukkan logik bahawa dalam sini A mesti siap, B mesti siap before C boleh dimulakan. Okay. So kalau kita gunakan activity on arrow, bermaksud A mesti siap, B mesti siap, tetapi we need a dummy to connect that. Okay, connection. Kita tak boleh teruskan ke sini. Kenapa? Sebab dia ada kaitan dengan D. D hanya memerlukan B sahaja. Okay, kalau kita connect direct, bermaksud A and B mempengaruhi D. Okay, I think that's enough for now. I will continue next class. Okay, please read the e-books. Otherwise, okay, you cannot follow in the speed that we are moving. Okay, because this is going to cover only for 2 weeks, so we have important information there. So it's good if you read before the next class. We go more detail on critical path method, PERT, and so on. Okay, so any question before I stop for today? Hello?